Bond polarity. Bond polarity. Talking about in a molecule, they have an uneven charge, like a positive in one end and a negative in the other end. A positive and a negative charge in a molecule. Student, early we learned ionic bond and covalent bond different. Ionic bond come from metal with a non-metal. So they form into a positive ion and a negative ion bind together, form into this ionic bond compound. Now we're going to focus on to the covalent bond, the covalent bonds molecule. The question is, do they have charge like ionic bond or not? Students very easy jump into conclusion, say, well, ionic bond have positive and a negative charge. Covalent bond must be no charge. And that's not correct. That's not total correct. Now we're going to look onto this covalent bond molecule in detail. This covalent bond. Electronegativities table. Electronegativities determine how the atom attract for electron. How they attract for electron. And you can see the number. The number of this numbering system. 4.0 is the strongest pulling for electron. Then it comes 3.5 weaker and weaker, 3.0, 2.5, and so on. The bigger the number, the stronger on electron pulling. The bigger the number is strong on pulling electron. Now we consider if you have two atoms, they bind together, what will happen onto the electron pulling? Now let's see. Electron dot diagram talk about molecule composition. Electronegativities will determine the molecule charge. Now let's start. HCl. HCl, H have 1 electron, Cl have 7 electrons. They form nicely into a covalent bond by sharing electron. Imagine now we consider the electronegativities table. In this table, you can see H is 2.1, Cl is 3.0. So the minus 3.0 is stronger on electron pulling than the minus 2.1. And then what will happen? Electron will more pull towards the Cl side. Electron will pull more towards the Cl side like this. And so you can see Cl have a stronger on electron attraction than hydrogen. H become positive because they have less electron, and Cl become more negative. Electron is negative, so you have more negative. Now it become a charged molecule. It become a polar molecule. So when there is a different, when you have two atoms, they different in electron negativities. One strong, the other one weaker. The electron will become uneven distribute. And this is going to form into a polar covalent. A polar covalent. That means they are a covalent bond, but they have positive and negative charge. They are a covalent bond, but they have positive and negative charge. Now, Now let's look on to another example, which will be different in this situation. Imagine if this is a H marry a H. They also form covalent bond, single bond. And now what happened to the electronegativities charge? They both are minus 2.1. So who is stronger on electron pooling? The answer is no one. They are equal. No one's going to be stronger than the other. So how is the electron will distribute this time? They will have the same electronegativities. So the electron will share equally. So this is going to be a non-polar covalent bond. So they are covalent bond, but they are non-polar. Because they don't have anyone stronger than the other and have no charge. I'll give another example of non-polar covalent. Oxygen, O2. They form double bond. They are covalent molecule too. And now see how's the electron distribution. See who is stronger. They both are minus 3.5. So who's going to be stronger? No one going to be stronger. Now again in the same situation, no one stronger. So the electron will share equally. So it's going to be a non-polar covalent bond. Another non-polar covalent bond. So student, now you learn of this covalent bond molecule. They can be, if they have different in electronegativity charge, because different in electronegativities, they will cause it to become polar. If they have different in electronegativities, will make it into a polar covalent bond. But if they have the same electronegativities, you will make it into a non-polar covalent bond. So conclusion, don't say ionic bond have positive, negative, and covalent bond always have no charge. That's wrong. Covalent bond could have positive, negative charge as polar, and it also can be non-polar too if they have same electronegativities. Now let's look more example about this polar covalent bond and the non-polar covalent bond. HCl, as we previously mentioned, they have a positive and a negative side because of uneven distribution. So they are a polar covalent. Water, H2O. Now look at this molecule. Where's the electron will distribute more? Electron will distribute more on the O side because O is 3.5. So O become more negative. So electrons are uneven distribute. Plus, water is a V-shaped molecule. So this uneven electron distribution make oxygen more negative, hydrogen more positive as a V shape. So it is a polar covalent. Look at nitrogen. Look at ammonia. the nitrogen of ammonia. Which ones have the strongest electron pooling now? N, 3.0. So electron will pull more towards the N. So N will become more negative. N will become more negative. And also the shape, this is a pyramid shape, and so electrons are uneven distributed. So ammonia is a polar covalent again, a polar covalent bond. Now let's look on to a non-polar covalent molecule like O2, double bond, but they are symmetric. The electrons are symmetric distribution. No one's get more electron than the other. So they are a non-polar covalent. CO2, when you first look, you say C is 2.5, O is 3.5, so electron will pull towards the O. But you look that on the other side also a O, so electron also pulling to the other side as well. So this makes the electron pulling symmetric, have an even electron distribution. Because of that, they also a non-polar. Methane, hydrocarbon. This look a more complex molecule. But you see which one's the strongest. The strongest is the C, 2.5, and the remaining is only 2.1. And electron all go towards the center, 2.5, and make the electron on all around even. Make all the electron, no one can pull towards one-sided. So now this become another non-polar molecule. Soon you're going to see in the future lesson, we will talk a lot of hydrogen and carbon, hydrocarbon, that's being a non-polar molecule in our future topic. So keep in mind, those polar covalent, they have positive, negative charge. Non-polar covalent molecule have no charge and are symmetric in electron distribution.